Hi guys, this is Mrs. Foy, and this is a quick little tutorial about classifying chemical reactions. So chemical reactions are pretty important in chemistry, right? So we have a chemical equation that shows us what goes on in the reaction. So everything to the left of the arrow we call a reactant, everything to the right of the arrow we call a product. And what happens in the chemical reactions is that the bonds between atoms and molecules break, and they reform new bonds to make new combinations. So here we have oxygen reacting with two hydrogen molecules to create two molecules of water. Water is the product, and hydrogen gas and oxygen gas are the reactants. So there's actually 5 different types of chemical reactions, 5 different classes. The first kind is called a synthesis reaction. A synthesis reaction is easy to see because there is always just one product, one compound to the right of the arrow. So here we have nitrogen gas reacting with hydrogen gas to form ammonia gas. And here we have another synthesis reaction of sulfur trioxide reacting with water to form sulfuric acid. So that's a synthesis reaction. If you just see one product, then you know it's synthesis. The other kind of reaction is called a decomposition reaction, which is actually the opposite of a composition reaction. In a decomposition reaction, you just have one reactant that decomposes or breaks apart. So here we have magnesium carbonate that breaks apart into magnesium oxide and carbon dioxide gas. Here we've got water decomposing into hydrogen and oxygen gas. So if you see one reactant to the left of the arrow, then you know you've got a decomposition reaction. Another kind of type of reaction is called a combustion reaction. And in a combustion reaction, we have some kind of fuel that reacts with oxygen. And in a lot of human activity, that fuel is a hydrocarbon, something that has carbons and hydrogens on it because it's a very rich source of energy. So when you have a fuel reacting with oxygen, it combusts, and it produces, in this case, carbon dioxide and water. So this is methane, which is natural gas, reacting with oxygen, forming carbon dioxide and water. Combustion reactions give off lots of heat and light, and we know this because that's why we burn fuel. This is another combustion reaction of a hydrocarbon called octane. This is one of the major hydrocarbons in gasoline, and it reacts with 25 oxygen molecules to form 16 molecules of carbon dioxide and 18 molecules of water. So that's a combustion reaction. Looking for oxygen as one of the reactants and some kind of fuel. If that fuel is a hydrocarbon, then it's going to produce carbon dioxide and water. The last 2 types of reaction are called single replacement and double replacement reaction. And just like the name says, something is replaced. So at first it looks like these are hard to see, but when you see the pattern, it's very easy. So in a single replacement reaction, you have one of the reactants is an element, right? So here I have zinc bromide reacting with fluorine. And what's going to happen is that the zinc is going to bond to the fluorine instead of to the bromine. So they're actually going to switch places, so to speak. So now on the other side of the reaction, zinc is going to be bonded to fluorine, and bromine is going to be produced. So one of the products is going to be an element. And I use a corny analogy sometimes, saying that you can think of this as a high school dance. So fluorine came to the dance by himself. Zinc is already coupled up with bromine, but then at the end of the dance, zinc is now dancing with fluorine, and bromine goes home alone. Here we have, and I should say in this reaction, I've got 1 cation and 2 anions. So I know that bromine and fluorine are not going to react together under normal conditions. So here I have aluminum metal reacting with hydrochloric acid. And what's happening here is the aluminum is actually more reactive. So it's going to kick the hydrogen off, and it's going to form aluminum chloride. And now hydrogen is kicked off, so he's going to go home alone. So look for a single element on the reaction side, and then look for a different single element on the product side, and chances are you've got a single replacement reaction. The last reaction type I want to tell you about is a double replacement reaction. So this is similar to the single replacement, except you've got two partners switching positions. So here we've got silver nitrate and sodium chloride. And this is going to be a double replacement reaction. So the silver, instead of bonding to the nitrate, the silver is going to bond to the chloride. So my silver is going to bond it to my chloride, and my sodium is going to be bonded to the nitrate. So we have a double replacement reaction. Silver is no longer bonded to nitrate. Silver is now bonded to chloride. Sodium is no longer bonded to chlorine. Sodium is now bonded to nitrate. And you have to use your good chemistry sense here. You're not going to have two metals reacting and two anions reacting, right? So you have your metal reacting with your non-metal, metal reacting with a non-metal. Another example here we have is iron sulfide reacting with hydrochloric acid. So what's going to happen here is that the iron is now going to be bonded to the chloride. Here I have iron 2 chloride over here, and then the hydrogen is left bonding to the sulfide. So both cations and anions switch places, and usually these are both going to be in an aqueous solution, and then they switch partners. There's some rules about the products that have to form. One has to form a precipitate or a gas, and your teacher will tell you more about those rules, but those are the 5 different types of chemical reactions.